In this video, I am going to introduce you to the differentiation of the implicit function. So let's talk about an example. So this is my function. So what I'm going to do, I'm going to consider this function. So I will write my function which is given as y cubed plus y squared plus 3xy plus 2y is equal to 7. Now what I'm going to do, I am going to differentiate on both sides. So I will write differentiating both sides with respect to x. So we will write d by dx of y cubed plus y squared plus 3xy plus 2y, that is equal to d by dx of 7, right? So now let's differentiate both sides of the function. So in order to do that, what I'm going to do, I'm going to distribute this d by dx inside the bracket. So if I do that, I will write this one as d by dx of y cubed plus d by dx of y squared plus d by dx of, my function is 3xy plus d by dx of 2y, that is equal to d by dx of 7, right? Now let's simplify further. So when I differentiate y with respect to x, I will get d by dx of y cubed is what? 3y squared, and since I am differentiating y with respect to x, I will get dy over dx plus d by dx of y squared is 2y, and then since I am differentiating with respect to y, I will write dy over dx, right? Plus my 3 is constant, so I will take 3 outside and I will write dy dx of xy, right? Plus my 2 is constant over here, so I will take 2 outside and I will write dy dx of y, that is equal to dy dx of 7 is 0 because 7 is a constant. Let's simplify further. So my first term is 3y squared dy over dx plus my second term is 2y dy over dx plus 3. Now I am going to distribute this d by dx inside the bracket, and if I do that, as you can see, this is my first function and this is my second function, right? So I'm going to simplify and I'm going to differentiate as a product of two functions. So I will write first function times d by dx of second function, right? Plus second function and then d by dx of first function, which is x, right? Plus 2 times d by dx of y is dy over dx, and that is equal to 0. Now let's simplify further, and if we do that, we will write this one as 3y squared dy over dx plus 2y dy over dx plus 3, and inside the bracket I have x times dy dx of y is dy over dx, right? Plus y times dy dx of x is 1, right? Plus 2 dy over dx, and that is equal to 0. Now I am going to simplify further, and if I do that, I will write this one as 3y squared dy over dx plus 2y dy over dx plus, I'm going to multiply 3 inside, so I will write 3 times x is 3x dy over dx, right? Plus y times 1 is y, so when I multiply 3, I will get 3 times y, which is 3y plus 2 dy over dx is equal to 0. Now, if you look closely, you can see I have dy over here, 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 and here. So as you can see, I can take my dy common. So if I take my dy common, I will write dy over dx is outside the bracket, and inside I have what? If I take dy over dx, I have 3y squared left, so I will write 3y squared plus, so for the second term, dy over dx is gone, so only thing left is 2y, so I will write 3y squared plus 2y plus, again here I have 3x left, so I will write 3x, right, plus my next term is 2, so I will write 2 plus, I have 3y, and that is equal to 0. Now, as you can see, only thing that I have that I can take to the other side is 3y, so I'm going to subtract 3y from both sides. And if I do that, as you can see, this term is gone, and I am left with dy over dx, right? And inside the bracket, I have 3y squared plus 2y plus 3x plus 2, and that is equal to negative 3y. Now, I'm looking for dy over dx, or I should say, we want to find dy over dx. So what we can do, we need to get rid of this coefficient that we have for dy. So I'm going to divide both sides by this term, 3y squared plus 2y plus 3x plus 2, right? I'm going to divide both sides by this term, 3y squared plus 2y plus 3x plus 2. And if I do that, as you can see, on my left side, this term is gone, so I am left with dy over dx, that is equal to, on the other side I have negative 3y over, I have 3y squared plus 2y plus 3x plus 2, right? And this is basically the differentiation of the given implicit function, right? And this is how we will find the differentiation of any given implicit function.